All right, so the focus of today's lesson is finding the volume of a pyramid. Let's start by taking a look at this image. The pyramid and the prism here have the same height and the same square base. When the pyramid is filled with sand and poured into the prism, it takes 3 pyramids to fill the prism. Use this information to write a formula for the volume of a pyramid. Pause the video, give it a try. So if you wrote V is equal to 1/3 base times height, where B is the area of the base and H is the height, then you wrote the correct formula. Let's find the volume of this pyramid. Example 1. So we know that our volume is equal to 1/3 the area of the base times the height. So first thing we identify is what is the base of this prism, or sorry, what is the base of this pyramid? The base here is a triangle. So our base is 1/2 4 times 6, which is 1/2 of 24, or 12. And we can see also that the pyramid has a height of 9 meters. So putting this information together gives us that the volume is 1/3 times 12 times 9. That is 1/3 of 12, which is 4, times 9, or 36 cubic meters. Now it's your turn to try. Find the volume of the pyramid shown. Pause the video, give it a try. Do note that the base is a square. Example 2. Originally, Khafre's pyramid had a height of about 144 meters and a volume of about 2,218,800 cubic meters. Find the side lengths of the square base. Okay, so we know that the volume is given by 1/3 base times height. In this case, we know that the volume is 2,218,800. And we know this is equal to 1/3 times the base times the height, which they tell us is 144. Let's start by simplifying this expression. So 2,218,800 is equal to 1/3 of 144, which is the same as 144 divided by 3, or 48. So this is 48b. We'd like to solve this equation for b, so we'll divide both sides of this equation by 48. So we will take the 2,218,800 and divide by 48. And we can see that the base is 46,225 meters squared. Now note here, this is the total area of the base. So we know then that the lengths, let's call them x, that x times x is the base. That is, x squared is our base. So in order to solve for x, we must square root our base. So we'll take the 46,625 and we will square root it because x is the square root of the base. In this case, x is 215. So we will then say one side of the base is 215 meters. All right, your turn. A square pyramid has a height of 12 centimeters and a volume of 64 cubic centimeters. Find the side length of the square base. Pause the video, give it a try. Example 3. Find the height of the triangular pyramid Okay, so once again, we know that the volume is equal to 1/3 the base times the height. In this case, our base is a triangle, and that is 1/2 times 4 times 3. That is 1/2 of 12, or 6. So our volume formula becomes volume, which is 14, is equal to 1/3 times our base area, which is 6, times our height, which is unknown. So simplifying, this becomes 14 is equal to 1/3 of 6, which is 2h. We would like to solve for h, so we'll remove the times 2, divide both sides of this equation by 2. 14 divided by 2 is 7, so our height is 7 feet. Now it's your turn to try again. Find the height of the triangular pyramid with volume of 384 cubic meters, a base that's a triangle with height 8 meters and a base of 24 meters. Pause the video, give it a try. All right, our last example. Example 4. Pyramid A and Pyramid B are similar. Find the volume of Pyramid B. Okay, remember when we talk about similarity that the scale factor is changed in relationship to the number of dimensions. So a one-dimensional similarity multiplies the scale factor once. A two-dimensional similarity, like area, multiplies the scale factor twice. And then a similarity between three-dimensional figures changes by multiplying the scale factor 3 times. So the first thing we need to do is identify our scale factor. That takes us from pyramid A to B. So we take our second value over our first, and our scale factor here is 6/8, which reduces to 3/4. So in order to find the volume of pyramid B, we will take the volume of pyramid A, and we will simply multiply by the scale factor once for every dimension. Because volume is 3 dimensions, we will do it 3 times. So we'll take the volume of A and multiply by 3/4 by 3/4 by 3/4. So ultimately, we're taking the volume of B and we're multiplying by 27/64. So let's go ahead and do it. Volume B is volume A, which is 96, times 27/64. Using a calculator, 96 times 27 becomes 2,592/64, and this becomes 40.5 meters cubed. Or, if we write it as a fraction, 81/2 cubic meters. Both of these are correct. All right, last one for you to try. Pyramid C and D are similar. Find the volume of Pyramid D. Given that the volume of Pyramid C is 324 cubic meters, with a base length of 9 meters, and Pyramid D has a base length of 3 meters. Pause the video, give it a try. Sorry, one more example. Find the volume of the composite solid. So this solid here is made up of a cube and a square-based pyramid. All right, so let's take a look. Let's start by finding the volume of the cube. So the volume of our cube is given by 6 times 6 times 6, or 216 cubic meters. Then we have the volume of our pyramid, which is given by 1/3 the area of the base, which is 6 by 6, or 36, times the height, which is also 6. So that is 1/3 of 6 times 6 times 6. So that's 1/3 of 216, which is 72 cubic meters. So the solid altogether has a volume of 216 plus 72, or 288 cubic meters. And last one for you to try. Find the volume of the composite solid. Once again, we have a cube, and then on top of the cube, we have a square-based pyramid. Now note here, they do not give us the height of the pyramid. So you might have to work at this one. Give it a try. Feel free to message me if you have questions. All right, now it's your turn to do the practice assignment. Go ahead and get this done. That way you have no homework.